In this episode, we're going to look at a Samsung HPS4253. This one has a discolored picture, almost a pink overlay in the background. It's hard to see unless you put up a white screen, but we're going to tackle this one and get it fixed up. The complaint on this one is like a pink blotch, and it's not showing up very well on camera due to the rolling shutter of the camera, but you can see the pink banding in the screen. That is the complaint on this set. And the cause of this is capacitors in the Y sustain board. So let's get this one apart and fix the problem. The problem doesn't show that well on camera, but it is very noticeable to the eye in the background, like almost like a pink tone on that white wall. And the fault certainly is evident when you put up the scrolling bars. It doesn't show as well on camera just due to the artifacts from the rolling shutter. But it's very noticeable when you bring up the scrolling bar as the picture gradually goes from black through to white. You can really see it right in that area of the screen. On this set, the board we're interested in is the Y sustain board, which is the large board on the left. That's the power supply I'm pointing out. And the X main is on the right. The Y main or Y sustain is the board on the left. This set uses a Korean-made panel. It has the voltages printed on the back, and this one, as you can see, was manufactured on May 26, 2006. The problem with this one is capacitors. There are bulging capacitors on the Y sustain board. There's one there, C5051. That is one that is obvious that is bad. If there's one that's bad, there's probably going to be others that the ESR is creeping up on. So what we're going to do on this set is we're going to pull the Y sustain board and go through it and change any of the caps that the ESR is starting to go high on and see if that gives us a better picture. Got to give the guys at Samsung credit for naming the board Model Porsche Cadillac. That's on the signal board. Anyway, let's get the Y sustain pulled. To remove this sustain board, we actually have to remove this panel with the signal board on it because there are connectors in behind there, and there's also screws that are in behind that are not accessible unless we remove this panel. So there's a little bit of work to get at the Y sustain board. You got to disassemble just a little more than, say, on some of the newer more modern televisions, which were a lot easier to work on. These old ones had a lot of boards and a lot of screws. And speaking of screws, make sure all the screws are tight because loose screws cause a lot of problems. Once all the screws are removed, it's just a matter of unplugging the sustain board from the buffer board. Just wiggle the board a bit and it will unplug. Now in behind here there is a strip of heatsink gel which is wedged in between the board and the chassis. This is used to keep the transistors cool. One also has to be careful that you don't damage the connectors in doing this. So once the board is disconnected, it can be just swung out of the way. You don't have to take that bracket out of there. There's the heatsink gel I was talking about. It fits on it sits on the chassis, and it just is pressed up against the back, and it's squeezed to the back of the power transistors, the IGBT transistors. So we have three capacitors on here that are obviously bulging. So we know these three definitely have to be replaced. One's a 220 at 50 and the other are 100 at 35 and a 100 at 50. I have some new parts here, brand new ones. I'm going to replace those three parts. I'm going to check the other ones as well to see if other ones are also going bad, but definitely these three have to be done. I want to try and repair this with the minimum parts that I can. I don't want to start changing parts willy-nilly because first of all, when I dispose of this TV, it's going to be one that I either sell or give away. Probably sell it. You know, I don't want to I don't want to put a lot of money into it because I won't get a lot of money for the set. And I want to try and get this thing going as reasonably as possible and show you what parts really go bad on these things and what parts you need to change. The most common parts, these three being. This is actually a power supply here. There's a little transformer. So these are one of the power supplies that derive voltage off of the main power supply to drive a specific voltage for one of the circuits on here. Right, you get a little optocoupler down here. So this is a sub power supply inside here, and these capacitors are going to be part of it. If we look at the Esr meter here on the the parts that we know for sure are bad. 1.2 ohms, that's bad. This one here, and it's coming up at 3.4. And this other one back here, this is the 220, it's coming up at 6.6. And it should be 0.3 as well. Looks like. No, 0.16. This is 6.7. Some of the other ones in the circuit here, of course, these ones are measuring okay, 0.09, right? So 0.09. So these other ones here that I'm checking here, these ones are okay. These other caps. It's just these three that are really bad. 0.8. What size of cap is that one? That one is a 200 volts, 47.8. 47 at 200 volts. Yeah, 0.8. So that one's okay. Looks to be just those three. So we'll just heat up the pins and pull the capacitor out. This is a plated board, so you actually got to put a fair bit of heat on these things to get them to come out. I already done one. I just have two more, this one and the last one, and then we'll put this back together and see how it looks. That's the second one in. One more to go, which is this one right here on the edge of the board. Same thing. We'll just heat it and pull it out, and then clean up the board once we've pulled out the cap. Okay, I've replaced the three capacitors. The capacitors were changed were C5065, yeah, 5065 right here. C5024 over here, and C5051 over here. Those are the three that were bulging. Those are the three that the ESR was through the roof. Those are the only three I've changed. Sliding the board back in, reseating it to reseat the three connectors. And line the board up with the mounting holes. To replace the four mounting screws, snugging them in good because these are critical grounding screws. Also likes to make sure that the grounding screws on the buffer boards are tight as well. Okay, we'll reconnect the signal cable here. And the power connectors. Okay, two power connectors on. We'll reseat latch it in place and reconnect the LDDS, and then reseat the two power connectors.
First thing we'll do when we reconnect everything and power it up is calibrate the voltage according to the chart on the back of the panel. So we'll hook the meter up and calibrate the panel.
So we've just got the ground probe to the meter going to the chassis. I'm going to set my VA adjustment as 65 volts. So here there's a VA adjustment and there's a test point. So I just put my meter on the test point. I see I'm at 66.1. So I'm just going to adjust the VA adjustment to get it to exactly 65 volts. Okay, and then we'll do the same thing for the VS. It's supposed to be 195. We're a little bit low, we're at 190.9. So I'm just going to take this up a bit. pretty darn close. We also have two other adjustments that are adjusted on this board here. We have our V-scan and our V-set. I don't know if you're going to be able to see what I'm doing here. The test points are underneath here, so I don't know if you can see whether I'm able to do it and see what we're doing here. But V-set's minus 195.4. It should be minus 190, so we're a little bit hot. So we'll just bring it down. Minus 190, and the other one here is a V-set. The V-set is supposed to be plus 195, and it's coming up at 206, so it's going to bring that one down just a smidge. Close enough. Let's take a look at the picture. I would say that that's a beautiful picture. This was a TV that was free. All I had to do was go and pick it up. A fantastic picture. Ah, it's excellent. Free TV, 3 capacitors. We'll catch you in the next one. Bye.